So today I'm going to discuss few more problems on infinite square well potential. In the last video, we discussed certain problems. This video is a continuation of that series. So let me start with the question number one. The question is the ground state. Apart from normalization of a particle of unit mass moving in a one-dimensional potential Vx is this. The potential Vx in the suitable unit so that the h cross equal to 1 planetary constant is there. Okay, so basically in this question, what we are asked is to find out the form of potential Vx. We have been asked to find out for a particle which is moving in a one-dimensional potential Vx and having the mass as unity, the ground state for that particle and moving one-dimensional potential Vx is given, which is let me write down as psi 0x e to the power minus x squared by 2 cosine hyperbolic root x. So this is given to us, and we have been asked to find out Vx in the unit and equal to h cross equal to 1. In the typical Schrodinger equation problem, we generally are given the form of the potential and asked to find out psi and e. But here the case is reverse. We have been given psi and asked to find out Vx. So we'll write down the Schrodinger equation for one-dimensional case, and then so one-dimensional Schrodinger equation is minus h cross by 2m which can be alternatively written as d2 psi by dx square psi. So this becomes d2 psi by dx square. Now since it is given that m and h cross both are 1, so I can put them m and h both 1, so I get e minus vx psi equal to 0. Alright, so this is equation number 2. Now the solution of this is already known to us, that is given in the problems as psi 0. So if it is a solution of 2, it will satisfy the equation. So we find out, let's say d psi 0 over dx from 1. So that will turn out to be e to the power minus x squared by 2 cosine, the derivative cosine is cosine hyperbolic is sine hyperbolic root 2x into root 2 and plus cosine hyperbolic root 2x e to the power minus x squared by 2 and minus x. And then you find out the second derivative d2 psi over dx2, which turns out to be root 2 sine hyperbolic root 2x e to the power minus x squared by 2 minus x plus root 2 e to the power minus x squared by 2 cosine hyperbolic root 2x into root 2 minus cosine hyperbolic root 2x e to the power minus x squared by 2 minus x cosine hyperbolic root 2 minus x e to the power minus x squared by 2. There is a term, so I can combine this term and this term. Okay, similarly I can combine this term and this term. So let's see what we get. We get the following. We get cosine hyperbolic root 2x into e to the power minus x squared by 2 plus x square cosine hyperbolic root 2x into the power minus x squared by 2 and the red terms together, which is minus 2 root 2 x e to the power minus x squared by 2 into sine hyperbolic root 2x. That's what we get. Okay, so when we put this equation 3, let's say in 2, we get the following. So put the equation 3 in 2. So put equation 3 in 2. So equation 2 is very simple. d2 psi 0 dx square, because psi 0 is the solution, so I have to replace that on psi 0 plus 2e minus vx psi 0 equal to 0. So d2 psi 0 or dx square is something which we have already calculated, and let me put the value here, and after putting the value we will get the following. So cosine, let me write down, x square cosine hyperbolic root 2x e to the power minus x square by 2 x square cosine hyperbolic root 2 plus cosine hyperbolic root 2x e to the power minus x square by 2 minus 2 root 2x e to the power minus x square by 2 into sine hyperbolic root 2x plus 2 into e minus vx, and psi is again e to the power minus x square by 2 cosine hyperbolic root 2x equals 0. Now if I take e to the power minus x square by 2 into cosine hyperbolic root 2x common, so I get x square plus 1 minus 2 root 2x 10 hyperbolic root 2x plus 2e minus 2v is equal to 0. Okay, so now this is nothing but psi 0. This is nothing but psi 0. So this expression gives us two possibilities: either psi 0 is 0, or the expression in the bracket is 0, in the closed bracket is 0. This psi 0 can't be 0, because this is given to us to be this expression. If psi 0 is 0, then it's a trivial solution. So we will take this bracket to be 0. So it implies that x squared plus 1 plus 2e minus 2 root 2x 10 hyperbolic root 2x is equal to 2vx. Alright, so let me divide by 2. So I get half of x squared plus 1 plus 2e minus 2 root 2x 10 hyperbolic root 2x as vx. So if we compare with the given option in the problem, if we check out the second option, that is x squared by 2 minus root 2x tan hyperbolic. This is the only option in which tan hyperbolic is given, and the expression is x squared by 2 minus root 2x times tan hyperbolic x. So if I open the bracket, this becomes x squared by 2 minus root 2x tan hyperbolic 2x, and this term is an additional term, which is a constant. E is in ground state is a constant, and plus 2 is a constant. In the question itself, it is given that up to an additive constant. So it means the option B of the given problem is correct. Option B of the given problem is correct. Okay, so this was a simple question. There's just some mathematical steps were involved, and let's go to the second question. This question was, by the way, asked in Jest. It is an Indian entrance examination, one of the toughest considered examination for MSc and PhD programs. So let's move to the other question, which is a particle of mass m is contained in a one-dimensional finite well extending from minus L by 2 to L by 2. So this is a one-dimensional potential box extending from minus L by 2 to L by 2. The particle in its ground state is given by. So the ground state of the particle, if suppose the particle is here of let's say mass m, so the ground state of this is given as root 2 by L cosine pi x by L according to the given problem. The walls of the box are moved suddenly to form a box extending from minus L to L. So what happens is suddenly the walls of the box are moved in such a fashion that the dimension of the box changes from minus L by 2 to L by 2 becomes minus L to plus L. What is the probability that the particle will be in the ground state after this sudden expansion. So what is the probability the particle will be found in the ground state after this sudden expansion? That's what the problem is asking. So now after the expansion, so ground state will be changed. Now let me call it psi 0 prime x. So that will be under, because the length of the box is now 2L, right? Length of the box is now 2L, earlier it was L. So it will be under root 2 over 2L cosine pi x by 2L. According to the given problem, that will be changed by 2L. So now the question is that what is the probability of the particle that it will be found in this ground stage? So that probability will be given as in the Dirac notation, that psi prime 0 x minus psi 0 x square and psi 0 x. Now this psi 0 x is normalized one, because if we integrate this cosine power x from minus L by 2 to L by 2, so we'll find that this is a normalized function. So this the denominator is going to be 1, and we need to calculate the numerator for that. Okay, so let me calculate the numerator. So first of all, let me calculate this guy, then I will square it. So this will be in the usual wave function form as this. I have to take the star of this, and then psi 0 x dx x in the form minus L by 2 to L by 2, like 2 over root 2 over L, and this becomes cosine pi x by L into cosine pi x by 2L dx, and x coming from minus L by 2 to. Okay, so we have to solve this expression, and I get as under root 2 by L minus L by 2 to L by 2 cosine pi x by L into cosine pi x by 2L dx. So I get root 2 by 1 into L, and now the integrand is even function with respect to very plus x by minus x. So I can use the property of the definite integral, and I can write as 0 to L by 2 cosine pi x by L and into cosine pi x by 2L dx. So if I take these two inside, I can use the trigonometric formula cosine a plus b, that is 3 pi x by 2L, plus cosine a minus b, which is pi x by 2L again, and the dx. Okay, so I take root 2 by L outside and I integrate. The first term gives me sine 3 pi x by 2L into 2L by 3 pi with the limit 0 to L by 2. The second term gives me sine of pi x by 2L in the 2L by pi with the limit 0 to L by 2. So if I calculate it, if I put the upper limit, so this becomes 2L by 3 pi sine 3 pi by 4, and the lower limit will make it 0. Similarly, the second term, if I write the upper limit will make it sine pi by 4, and the lower limit will make it 0 again. So I take the 2L by pi common, so under L upon 2L upon pi outside, so 1 over 3. Sine 3 pi by 4 is sine pi minus pi by 4, which is sine pi by 4, and this is 1 over root 2. Similarly, if I take 1 over root 2 here, so this gives me 2 by pi into root 2 into 4 by root 2, 3. So root 2 cancel this, I get 8 by 3 pi. Okay, so this was psi 0 prime x, psi x. If I take the I want to find out the probability of getting found in ground state. So that will be the square of this, as we discussed. Okay, the square of it, and that turns out to be 8 by 3 pi. This is the right answer. So that's it for today. So we solved two questions, otherwise this video will become too long. Attention.